Our next unit is on forces. There'll be two videos. This first video will cover more of the simple aspects of forces, and the second video will concentrate on the more complex aspects of forces. We'll start off with the basic equation, which is force equals mass times acceleration. Force is given with the capital F, and the unit is in newtons, which is a large N. Mass is a small m, given in kilograms, and as you've learned before, acceleration is a, and that is meters per second squared. So let's say that we have a mass of 2 kilograms and it's undergoing an acceleration of 5 meters per second. How much force was needed to accelerate this object? And very simply, 5 times 2 is 10 newtons. Another aspect of this is that weight is a type of force, and weight is dependent upon the gravitational field that you're in. Here on Earth, if you remember, we've talked about 9.81 meters per second squared is the acceleration due to gravity. If we go to Mars or the Moon, the gravitational attraction will be less. If we go deeper into the Earth, the gravitational attraction will be more. If we go to Mount Everest, a little bit further away from the center of the Earth, the gravitational attraction is less. But just say that for an average near surface situation, we're going to go with 9.81. So some object that has 2 kilograms of mass, how much will that weigh here at the surface or near surface of the Earth? We multiply that by the acceleration, 9.81, and we come up with 19.62 newtons. Okay, we're now going to take a look at force net. Force net is very useful because this will give us a sum of all the forces that are acting on an object, and we'll represent this by Fn. Let's say we have a block and I'm applying a force of 10 newtons to the right, but there's also a resistance force of 7 newtons going in the opposite direction, and it could be anything. It could be friction, it could be somebody else pulling on it, it could be wind, whatever. But to find the force net, we will take the force applied minus the force of resistance. Since the applied force is 10 and the resistance force is 7, I will subtract the 2, and what we end up with is 3 newtons to the right. Now, I want to take this a little bit further and find out the acceleration at which this will go. Well, I can go back to this equation. Force equals mass times acceleration, and let's say this just happens to be 3 kilograms. So I have a net force of 3 from here. I have 3 for the mass. How much acceleration is this block experiencing? And we do the math and come up with 1 meter per second squared. The next force that we're going to look at is applied forces at an angle. We just looked at forces going horizontally, and now we're going to take a look at a force going in this direction. It's a 10 newtons in this situation, but it will not be 10 newtons horizontally. If we do a 3, 4, 5 triangle, you can see that we only have 8 newtons of force going in this direction now. And the other thing that we'll take a closer look at later on is this upward force of 6 newtons reduces the weight of this box. Okay, here's another example. Let's say that we have a rope pulling a box at 60 degrees to horizontal, and we have a force of 10 on here applied to it. Well, if we take force applied sine 60, that will give us this force here. If you look at the equation, this is 10, sine of 60 is 0.866. That gives you 8.7 newtons worth of force in this direction. And horizontally, you'll only have 5 newtons because force applied at 10 newtons cosine 60 gives you 0.5, and this will give you the 5 newtons going in this direction. Okay, and so now you look at this and you say, well, what kind of acceleration do we have on this? We have an applied force of only 5 newtons, and let's say we have a mass of 1 kilogram, and we want to know what the acceleration is. The acceleration will be 5 meters a second squared. The next force we'll look at is the force of friction. Force of friction is equal to the coefficient of friction times force weight. Let's go back to the coefficient of friction for a second. It is given by a symbol mu, it's a Greek letter, and there is no one number for this. It varies for every situation, and so you'll either be asked to calculate it or it will be given to you to help solve the problem. So there's nothing to memorize here. It will be either given to you or you'll calculate it. And if I take this equation and just use an example, let's say I have a box going across a table, and for some reason I know that mu is 0.5, and I know that it has a weight of 20 newtons, then the force of friction is 10. Now, if I were to add on another 40 pounds to this, then this would be 60 times 0.5, and the force of friction would be 30. So the weight as it pushes down on the surface is very critical to the force of friction. Let's do an example here. Let's say we have a box. I'm pulling it in this direction at 25 newtons, and the force of friction, which I've calculated, is 10. Okay, we take force net equals force applied minus force of friction, 25 minus 10. That means that the actual force here, the total net force in here, is 15 newtons. How fast will this thing accelerate? Force equals mass times acceleration. Mass of 10, here's the acceleration. Do the math. Acceleration is 1.5 meters per second squared. Let's take a look at a problem using most of what we've talked about. What is the acceleration of a block under the following conditions? I have a block. I'm applying a force in this direction of 20 newtons, but there's a frictional force that is in the opposite direction. This thing weighs 10 kilograms. We have a coefficient of friction of 0.2. Okay, so what we want to know is the net force. We're going to find the net force so we can plug it into here, and we'll know the mass, and then we can find the acceleration, which is what we're asking up here. But first we got to find the net force. Okay, we know we have an applied force of 20. Force of friction is coefficient of friction times force weight. If you remember, force weight is mass times gravity, so I can break that into that, and the whole equation is force of friction force of friction is 0.2 times 10 times 9.81 subtracted from 20, and this comes out to be 19.62 minus 20. The net force is 0.38 newtons. Now I can plug in this to the force here. I know this is 10, and the acceleration that this block will experience will be very small, 0.038 meters per second squared. This is where we'll stop for right now. There's still a lot of other things that we need to cover, and we'll cover a lot of this in class. We have to cover static and kinetic friction. We'll take a look at how weight influences this and how weight is determined by the gravitational field. We'll look at applied forces that are not either horizontal or vertical but are at an angle, and how that relates to the frictional force. If you remember, at an angle we have an upward force, which will then have to be taken into account in terms of force weight, because an upward force would reduce the amount of force weight on this. It gets fairly complicated, but this will all be in the next section.